this problem, we will talk about how to solve like very popular graph problem. Since this problem is very popular, I want you guys to try this on your own and try to solve this problem without modifying the given input. So pause this video for a second and read this problem statement. Let's try DFS first. This is my DFS function, and you notice that we have a lot going on here, but basically x and y will be x coordinate and y coordinate. This first one is testing whether my x coordinate is valid or not. Same for the y coordinate. You are basically checking whether grid at x comma y is equal to 1. That means this is a land and we can run DFS. Lastly, this part is very key, that x comma y is not in visited. So because of this guy, we don't have to modify the given input and we can just use visited, which is a set, to solve this problem without modifying the given input. So let's run DFS on this guy. DFS of 0, 0 with some grid given. So grid is this guy and visited as of now is just an empty set. You notice that 0, 0, this checks every condition here. So we move to the next part. So we move to this guy and we add 0, 0 to our visited set. And here you see that I added 0, 0 in my visited set. I highlight it under yellow and you run DFS here. So my DFS would be, you look to the right and that is this guy, 0, 1, and I run DFS of 0, 1. You run it and you notice that 0, 1 is not in visited, so we can run this if statement. We add 0, 1 to my visited set, so that's what I just did, and I mark it on the yellow and you run DFS. Here you keep going to your right and now we are at here. So we run DFS of 0, 3 and you notice that to your right this is 0. This is not equal to 1. So you backtrack. So from here you notice that this is 0, you backtrack. Then you look to your left. You look to your left and 0, 2 is already in my visited set. So you backtrack again. You look to your north and you see that this is not a valid coordinate. So you backtrack and you look to your south. So that's the fourth, that's this guy. Then you run DFS on this guy. That's what I just did. And in this case, if you look at here, this guy is 0, this guy is 0, this guy is 0, and this is already in my visited set. So you backtrack, and then here you'll be looking at this guy, and then here. After many steps, you basically visited all the islands, and there you go. So notice that here we have only one island, and so that's pretty much it. Write a code for this problem. This time is DFS first. Okay, so let's write count equal to 0. This is what we will return, and we have visited is set, and we run this guy for I in range length grid, for j in range length grid at 0. If grid at I comma j is equal to 1 and I comma j is not in visited, then we run DFS. Okay, self DFS. So let's define DFS. Self, and we need x comma y comma grid and visited. And we have that long if statement. We have if 0 is less than or equal to x len grid, and 0 is less than or equal to y len grid, 0, and grid x comma y is equal to 1, and x comma y is not in visited, Then we add this coordinate into our visited set, x comma y. We run DFS, x plus 1, y, grid visited. And then here we have x minus 1, we have x plus 1 minus 1. Now we have our DFS function defined, so we send I and j and grid and visited, and we increment count by 1, and we return count. This should be it. So let's run this. Okay, so this is our DFS approach to this problem, and let's try BFS. So this is my BFS approach, and BFS approach is, once you understand this, you don't have to memorize BFS code. It's very straightforward. And if you look at my if statements here, this conditional statement is exactly the same that you just saw in my DFS code. Exactly the same. Here you are adding that coordinate into our set visited. The only difference is that I have an array, actually a deck, and we call that queue. You run this until our queue is empty. So let's run this. So we will have, say, BFS of 0, 0, grid visited. Queue will have 0, 0, and then the length is just n is just 1 in this case. Current position would be, you pop leftmost guy, there will be 0, 0. Current x, current y, there will be just 0, so current x will be 0, current y will be 0. You have 4 possible choices of direction. So -1, 0 means you are looking to your left. 1, 0 means you are looking to your right. 0, -1 means you are looking downward. 0, 1 means you are looking upward. So you try all this direction, and we have a new variables, u underscore x. There will be current underscore x plus direction, the first part of the direction, there will be -1. U underscore y will be current underscore y plus direction of the second guy here. And you check whether they are valid coordinates. So there will be 0 is less than or equal to u underscore x. So things that we just saw. We also check if this guy and this guy are equal to 1, and make sure that they are also not invisited. If they are not invisited, then we add, say in this case 0, 1 will be added into our visited set, and we append that into our queue. So right now our queue is empty, but we append 0, 1, so our queue will be 0, 1. And you add this guy too, 1, 0. They are not, it is not in our visited set, so you add that to our visited set, and you append that number 2 coordinate to our queue. So our queue here, we will have 0, 1 and 1, 0. And this is our visited set. And you look at the neighbors of these two guys. So all the possible neighbors are this, this, and this. Since this guy are invalid tiles coordinates, so these 3 are the only possible neighbors for these 2 guys. And you add these 3 to our queue, and then you look at the neighbors of those three guys. There will be just 1 and 1. These 2 are 0, so you just forget about it. And you keep doing it until you are exhausted. Basically, you cannot move any further. Then you exit your BFS function, and that's it. So let's look at the code. Okay, so let me just copy and paste my BFS code for this, because I don't want to waste you guys time on me typing this code. So basically this is my BFS code for this problem, and okay. So yeah, basically so exactly identical like in this part. So we have a we have two for loops, and if grid at I comma j is equal to 1 and I comma j is not visited, we run BFS. And then once you exit the BFS function, we increment count by 1, and this is my BFS approach. And yeah, that's it. And let's run this. Okay, so this is my BFS approach for this problem, and as you can see, so if you look at the official solution for this, I was a little bit disappointed that they modify the given input. I don't think that should be allowed. Yeah, I think that's pretty much it. And if my video helps, please subscribe to my channel. I will see you in my next video. Thank you so much, you guys, for your time, and have a great evening. Bye bye.